As of January 2021, there are 4.66 billion internet users all over the world. That's 59.5% of the global population. As humans living in the innovative world, we've all heard of the word internet. According to the Cambridge Dictionary, the internet is a large system of connected computers around the world that allows people to share information and communicate with each other. This is the literal definition of the word internet. But what does that mean, and how does the internet work? Let's find out. To know how the internet works, we need to know what computing devices are. Computing devices are electronic devices that take inputs, process the inputs, and then calculate results from the inputs. In simpler words, they are the mathematical devices that help us do math in a much faster way. One of the most common computing devices is the computer, which we all know about. A computer network is made up of many computing devices that communicate and share information with each other. The computers use common communication protocols over digital interconnections to communicate with each other. Computing devices in a big computer network communicate with each other using bits. In the computing world, we use binary number notation, also known as the base 2 number notation. Each digit is called a bit and can only store the value of 0 or 1. 8 bits grouped together are called a byte. Each byte can store one character. With bits and bytes, computing devices can send signals to each other as long as they follow certain sets of rules that define how data should be transmitted between computing devices. These rules are called Internet protocols and are also known as IPs. Each computing device has a unique numerical IP address, such as 236.8.0.3. An IP address allows information to be sent and received by the correct parties, and can also be used to track down a user's physical location. The internet is similar to a road network. It has rules that you need to follow, and only a certain amount of cars can get through at a time. If too many cars try to go down the same road, the traffic gets congested. Therefore, there's a limit of how many cars can go down the same road at the same time. In this road situation, the rules represent protocols, cars represent data, and the limit of how many cars can go down the same road at the same time represents the bandwidth. The case of traffic congestion, in the context of the internet, is known as reduced bandwidth. To decrease the bandwidth used when sending data compression is used. Data compression is condensing large files into much smaller ones by getting rid of data that isn't needed. There are two types of data compression: lossless compression and lossy compression. Lossless algorithms are those that can reconstruct the original message exactly from the compressed message, while lossy compression can only reconstruct an approximation of it. Lossless compression is typically used for text and lossy compression for images and sound, where a little bit of loss in resolution is acceptable. Lossless compression packs data in such a way that the compressed packet can be decompressed, and the data can be pulled out exactly the same as it went in. This is very important for computer programs and archives, since even a very small change in a computer program will make it unusable. We often use the terms Internet and World Wide Web interchangeably in casual conversations. However, the two terms refer to different ideas. The Internet is a vast network that connects computers all over the world. Meanwhile, the World Wide Web is a collection of interlinked website documents viewed with a web browser by typing an address. The Hypertext Markup Language, also known as HTML, is a standard markup language for web pages. Most web pages use HTML to run on web browsers. Web browsers use Hypertext Transfer Protocol, also known as HTTP, to interpret web pages. HTTP is an application layer protocol for transmitting hypermedia documents, such as HTML. It was designed for communication between web browsers and web servers, but it can also be used for other purposes. The domain name system, known as DNS, is the phone book of the internet. Humans access information online through domain names, like google.com or youtube.com. Web browsers interact through IP addresses. DNS translates domain names to IP addresses, so browsers can load internet resources. While streaming data over the internet, resources are divided into packets that the IP sends individually through a route. Each packet contains data and metadata. Metadata is the data that provides information about other data. In the context of sending a photo, the photo itself is the data, and the part about its file format is the metadata. Although the internet is reliable, once in a while a packet will be lost. When that happens, devices need to decide whether the faults are important. For example, if one video frame is lost, the lost frame will be imperceptible to the viewer, so the loss can be considered unimportant and can be disregarded. When the faults are important, TCP is used. TCP stands for Transmission Control Protocol. It works by continuously sending packets until an acknowledgement of proper receipt is sent back. TCP keeps track of which packets it receives successfully and resends any that have been lost or damaged. In addition, TCP communications indicate the order in which data packets should be received and confirm that packets arrive as intended. If a packet does not arrive, TCP requires that it be resent. When the faults are less significant, UDP is used. UDP stands for User Datagram Protocol. It works by sending packets directly to a target device without establishing a connection first, indicating the order of packets, or checking whether they arrived as intended. UDP allows data to be transferred very quickly, but it can also cause packets to become lost in transit. Another critical design aspect of the internet is its scalability. The scalability of a system is its capacity to change in size to accommodate a greater amount of usage. A system is scalable when it can handle a significant amount of usage. Since the internet has global outreach, scalability will always be an important area to be given attention to. To wrap up, a computer network is made up of many different computing devices that communicate with each other through internet protocols using zeros and ones. To make communication faster, data is compressed using either lossless or lossy compression, depending on its nature. When we search for websites, the DNS translates domain names into IP addresses that allow HTML codes to be interpreted by HTTP. TCP and UDP are two methods of sending information across the internet, one with ensured successful packet arrival and one without it. And that is the Internet explained.